All right, everybody, welcome back to Math 113. As per request, we get to see the raw notes that I have built everything on. So we begin with an example. Actually, we can move directly into section 8.1. So section 8.1 is on testing a claim about a population proportion. We can use the critical value method, the p-value method, or confidence intervals to test the claims. Now, we can test using the normal approximation method as well. So this involves a binomial distribution. Okay. Now, n is the sample size or the number of trials. P hat is x divided by n, which is the sample proportion, where p is the population proportion. And of course, q is equal to 1 minus p. So what are the requirements to use this method? Well, the requirements are we have a simple random sample. They satisfy conditions for a binomial distribution. We have NP is greater than 5 and n times q is greater than or equal to 5, right? So the binomial distribution of sample proportions can be approximated by a normal distribution, okay, with mu is equal to n times p, or sigma is equal to the square root of n times p times q. So p is the assumed proportion, not the sample proportion p hat. Okay, so your test statistic here, okay, we would be using a z statistic. Ignore where it says test. This is obvious that I'd be testing something like this, right? We have our test statistic z equals p hat minus p over the square root of p q over n. So this is one fraction, right? And let's go ahead and recall the previous example we've looked at. Okay, please ignore the small letters. Again, this was by request. So, for example, 1,009 consumers are selected. 54% were not comfortable with drone deliveries. Okay, so we want to test that most people are uncomfortable with drone deliveries. So let's check the requirements. Well, are we randomly selected? Yes, the consumers are randomly selected. Are there a fixed number of trials? Yes, there's 1,009. Is n times p greater than or equal to 5? Well, greater than 5, much greater than 5 in this case, because n is 1,009, and we're given that p is equal to 0.5 because we're just testing to see if the majority of individuals are greater than 0.5. So that's just what we're testing here. And n times q, obviously q is 1 minus 0.5. We get 1,009 times 0.5. And of course, these numbers are both great. They're large enough. So what do we know? We know that the null hypothesis, right, could be that p is equal to 0.5. And we can write or state our alternative hypothesis, right, because we're testing to see if the majority of individuals are comfortable or are not comfortable with drone deliveries. Okay, so we have HA is that P is greater than 0.5. And our alternative hypothesis has no equal sign, right? Our null hypothesis has our equal sign in this case, as we would usually expect. So let me read the example one more time. 1,009 consumers selected, right? 54% were not comfortable with drone deliveries. We want to test that most are uncomfortable. So most are uncomfortable, that's what we're getting at here, given that 54% were not comfortable with drone deliveries from that 1,009 value. So we go ahead and we apply what we know. Part 4 of these problems is to select your alpha level. Alpha is 0.05. P hat is relevant because the sample proportion targets the population proportion. So we know that P hat is relevant. So this proportion follows the normal distribution, okay? And we have z, our z value, our z statistic, okay? That's equal to p hat minus p, all divided by the square root of pq over n. So we just plug in our information. We know from this example previously that we plug in, we have 545 over 1,009. That was p hat, that was the amount of people uncomfortable divided by the total amount of people tested, minus 0.5, right? Our value for p, we assumed, okay? And then in the denominator, we have the square root of this whole fraction, 0.5 times 0.5 over 1,009, and we get we have a right-tailed test because in our alternative hypothesis, we have p is greater than 0.5. So when we go forward, we get a value z is equal to 2.55. Our p-value is the area to the right of this z-score, these z values, the z statistic that was calculated. So we go ahead and we find out what the area to the right of it is, okay? And the area to the right of it was equal to 0.0054. Now, how did I do that? I used the chart method, which you could have used as just the normal distribution to find out what the probability is to the right of 2.55. You just do norm distribution, z-score is 2.55. You use that, you'll get 0.9946. You subtract that from 1, and in the tail we have 0.0054, which means we're in the rejection region. So that means that because 0.0054 is less than alpha, it's smaller than 0.05, we reject our null hypothesis, and then we conclude by saying there's sufficient evidence to support that the hypothesis, that over half of customers are uncomfortable with drone deliveries. Okay.